In the first part of this journey, we asked a question that has fascinated humanity for centuries: where beyond Earth could life exist? We examined the inner solar system and saw that among the rocky planets, Mars appears to be the most promising candidate. But what happens if we continue our voyage outward? Once we pass Mars, we leave the so-called Goldilocks Zone, that narrow band around the Sun where conditions are just right for life to survive on the surface. Beyond this point, the worlds grow colder, darker, and stranger. And yet the further we travel, the more fascinating the possibilities become. The gas giants and ice giants come into view, each surrounded by moons that are worlds in their own right. Could some of these moons, hidden under thick shells of ice or cloaked in exotic atmospheres, be home to life? Let's set our course into the outer solar system and explore where scientists believe life may be hiding. The first planet we encounter after Mars is Jupiter, the largest planet in the solar system. At first glance, it seems like the least likely place to find life. Jupiter is a storm-ridden world with no solid surface. Its atmosphere is dominated by violent winds, monstrous storms, and immense convection currents. Any microscopic organism drifting in the upper clouds would quickly be dragged downward into regions of crushing pressure and searing heat. The deeper we go, the harsher the conditions become. On Jupiter itself, life as we know it appears nearly impossible, but the story doesn't end here, because orbiting this giant planet are dozens of moons, and among them are some of the most promising places to search for life anywhere in the solar system. Of Jupiter's many moons, 4 stand out for their size and complexity. These are the Galilean moons, Io, Europa, Ganymede, and Callisto. Let's focus on Europa, a world that captures the imagination of scientists and storytellers alike. From space, Europa's surface looks like cracked glass, crisscrossed by endless fault lines and fractures. At first, it may appear barren, but this icy shell hides an astonishing secret. Beneath its crust of frozen water lies a vast global ocean, not just pockets of liquid, but an entire layer of water, possibly deeper than all of Earth's oceans combined. How do we know? This one clue comes from Europa's rotation. Observations suggest its icy crust has shifted by up to 80 degrees. Relative to its interior, something unlikely if the crust and core were firmly attached. Another piece of evidence comes from spacecraft. When NASA's Galileo probe flew close to Europa, it detected water plumes erupting hundreds of kilometers into space. Later, the Hubble Space Telescope imaged similar geysers, and the re-examined Galileo data confirmed them. These discoveries make Europa one of the most intriguing destinations in the search for extraterrestrial life. So intriguing, in fact, that NASA is preparing a dedicated mission, the Europa Clipper. When it launches, it will pass repeatedly through Europa's geysers, sampling the water vapor directly. We shouldn't expect to see fish blasted into space, but those samples could reveal whether the hidden ocean contains the chemical ingredients of life. Future missions may one day attempt to drill or melt through Europa's ice, sending probes into the dark ocean below. For now, though, we can only imagine what might be swimming in those depths. Europa isn't alone. Other Galilean moons may also host subsurface oceans. Callisto, scarred and ancient, may hide a water or ice layer up to 300 kilometers thick. Ganymede, the largest moon in the solar system, appears to hold several layers of water, each separated by sheets of ice. What makes Ganymede especially interesting is the possibility that its lowest ocean rests directly on rocky seafloor. Why does this matter? Because contact between water and rock allows chemical reactions that can provide nutrients and energy for life. On Earth, this kind of interaction powers ecosystems around deep-sea vents. Data also suggest that Ganymede's underground ocean might be the largest in the solar system. And just like Europa Ganymede will soon have a visitor, the European Space Agency's JWST mission arriving in the 2030s to investigate its secrets. But wait, how can these moons so far from the Sun have liquid water at all? Shouldn't they be frozen solid? The answer lies in heat. Some of it comes from tidal forces as Jupiter's immense gravity flexes and squeezes the moons, generating internal warmth. But scientists also propose another mechanism, Rossby waves. These are planetary waves caused by rotation similar to those found in Earth's atmosphere and oceans. Slow-moving but powerful Rossby waves can store enormous amounts of energy. Over time, this energy may help keep subsurface oceans liquid and even create currents, much like those in Earth's seas. This means that beneath the ice, the oceans of Europa, Ganymede, and Callisto may not be still and lifeless, but dynamic with currents and circulation. In such an environment, could life exist? To answer that, let's remind ourselves of the key ingredients needed for life. First, liquid water, and here we already have it. Water is essential not only because it allows biochemical reactions, but also because it acts as a solvent carrying nutrients and molecules in and out of cells. Second, an energy source. Sunlight won't reach these oceans, but energy may come from tidal heating chemical reactions, or perhaps hydrothermal vents. Third, the right chemistry. Carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. The building blocks of life need to be present. At the bottom of Earth's oceans, far from sunlight, ecosystems thrive around hydrothermal vents. Here, bacteria use chemosynthesis instead of photosynthesis, extracting energy from chemicals released by the vents. Around them grow entire communities of snails, shrimps, crabs, and fish surviving in extreme heat and crushing pressure. If similar vents exist at the base of Europa's or Ganymede's oceans, then perhaps life there is not only possible but even likely. Moving farther out, we reach Saturn and its retinue of moons. Like Jupiter, Saturn itself is inhospitable, but among its moons one stands out as an extraordinary candidate, Enceladus. Enceladus is small, barely 500 kilometers across, but incredibly active. Along fractures known as tiger stripes, geysers, blast water and minerals into space at over 2,000 kilometers per hour. This tiny moon ejects so much material that it actually creates a faint ring around Saturn known as the E-ring. When the Cassini spacecraft passed through these plumes, it detected water organic molecules and the essential elements for life: carbon, hydrogen, nitrogen and oxygen. Heat maps revealed warm regions beneath the ice, pointing to hydrothermal activity. This combination liquid water chemistry and energy makes Enceladus one of the best places to search for life in the entire solar system. Some scientists even argue it is more promising than Europa, and yet there are no missions currently approved to return to Enceladus. For now, its secrets remain locked away, waiting for the day we send another spacecraft to dive through its geysers. Enceladus is not the only intriguing moon. Rhea, Saturn's second largest moon, may also contain hidden oceans. Around Uranus, Titania and Oberon show signs of internal water. Neptune's moon Triton, captured long ago from the Kuiper belt, could also conceal liquid beneath its frozen crust. These worlds remain mysterious, largely unexplored, but they remind us that oceans may be common in the cold reaches of the solar system. Beyond the gas giants, the dwarf planets hold potential too. Pluto, Eris and Sedna are distant icy bodies at the edge of the solar system. If they follow the same patterns as the moons we've seen, they may also harbour subsurface oceans. For now, we have only tantalising hints. The New Horizons mission revealed Pluto's surface to be surprisingly active, with flowing glaciers and icy plains suggesting internal heat. Could an ocean lurk beneath? The possibility remains open. Among Saturn's moons, one world is unlike any other Titan. Titan is larger than Mercury and wrapped in a dense atmosphere of nitrogen and methane. The surface is unimaginably cold, far below freezing, but here methane behaves like water does on Earth. It rains, it forms rivers, it collects in seas and lakes. Titan even has a methane cycle echoing Earth's water cycle. This raises an extraordinary idea. Could life exist that doesn't use water at all, but instead uses liquid hydrocarbons? In theory, such organisms could breathe hydrogen, instead of oxygen consume acetylene, instead of glucose and exhale methane, instead of carbon dioxide. Titan has often been compared to primordial Earth, frozen in a distant time. NASA once proposed a mission to send a floating probe onto Titan's lakes, but the idea was never funded. Many scientists still believe that exploring Titan's seas would be easier than drilling into Europa's ice, and potentially just as revolutionary. Beyond planets and moons, even comets have been considered. A long-standing theory called panspermia suggests that life might spread between worlds aboard these icy wanderers. When the Rosetta mission's Philae lander touched down on Comet 67P, it found complex organic compounds and clumps that resembled viral particles. These discoveries were surprising and difficult to explain with chemistry alone. Does this mean comets carry life? For now, the idea remains controversial, but comets may at least be rich with the raw materials that help life begin. So where does this leave us? Across the outer solar system, we see frozen surfaces hidden, oceans, exotic chemistry, and powerful energy sources. Worlds that at first glance seem hostile may, in fact, be havens for life. Europa's fractured ice, Enceladus's geysers, Titan's methane lakes, Pluto's hidden heart. Each of these places whispers the same message. Perhaps Earth is not unique. Perhaps life is not confined to one blue planet orbiting a single star. We are still far from knowing the truth. Reaching these oceans and probing their depths may take decades, but the search itself is one of humanity's greatest adventures. Let's keep asking the question, keep building the missions, and keep looking outward. Because somewhere in the dark oceans of a distant moon, life may already be waiting, and this is only part 2 of our series. In the next chapter, we will journey beyond our solar system to explore the most likely places for life among the stars. If you enjoyed this exploration, don't forget to like, share, and subscribe. Your support helps us continue our voyage through the cosmos. Thanks for watching Cosmic Compass. Until next time, let's keep our eyes on the stars.